So I'm not going to explain every single question. I'm just going to explain some of them. Let's start with number one. They want us to graph and state everything possible about this exponential function. Before we begin, is this a exponential growth or a decay function?
Decay.
Decay. Notice I have right here the 1/2. So the base, if it's a fraction that's less than 1, then it's a decay. If it's a fraction greater than 1 or a value greater than 1, it's a growth. And that makes total sense, because if I take any number like the number 8 and multiply it by half, it's going to get smaller. If I had a base of 2 and I took any number and multiplied it by 2, it'd get bigger. So if the base is less than 1, it's going to decay. If the base is greater than 1, it's going to grow. So on the previous notes I've given you right here, you want to start by ignoring your h and k values. I always say box this in right here. Please follow along in your homework. And I say make a quick XY table with consecutive integer inputs. That means in order, -3, -2, -1, 0, 1, 2, 3. The reason why they're in order is because we're going to be able to use the pattern because the inputs are in order. So let's plug in one of these inputs. The easiest one to plug in is 0. So if you put a 0 right there where the x is at, you're going to have 1/2 to the 0 power. And what's 1/2 to the 0 power? Anything to the 0 power is what? 1. So this is really 1 and then times 4. What's 1 times 4? 4. So when I plug in a 0, I get out a 4 on the parent graph. Remember, we are ignoring the k value right now, which is the asymptote value. But anyways, we're ignoring this guy. We're going to do a -2 shift later on. We're going to shift the whole thing down 2 units because of this k. But anyway, right now we're just focusing in on this. And we plugged in 0, we got out a 4. Now, the beauty of having the inputs in order is to get the next output, you simply look at this decay factor, and you know that 4 is going to decay by 1/2. Now, what does that mean, that 4 is going to decay by 1/2? I'm going to take the 4, and I'm going to multiply it by 1/2, and I'm going to get my next output. What is 4 times half? That's 2. And then I'm going to take that 2, and then multiply it by 1/2, and I'll get my next output value. What's 2 times half? 1. And then multiply that by half. What do you get? 1/2. And you could keep going if you wanted to. You could put a 4, and then what's the next one? 1/2 times 1/2? 1/4. And so on and so on. It keeps getting closer and closer to 0. Now, if we know this is dividing by 2, or really multiplying by half, multiplying by half, multiplying by half, going backwards, it's actually going to be multiplying by 2, okay? Because 4 divided by 2 is 2, 2 divided by 2 is 1, 1 divided by 2 is 1/2. But if we go backwards and take 1/2 times 2, we'll get 1. 1 times 2, we'll get 2. 2 times 2 is 4. So what's the next one up? 8. And the next one? 16, but we're not going to use that because it's already off the graph. So pretty much, I'm just going to use these coordinates right here. And these are your parent graph coordinates. So let's graph those. -1 on the x, 8 on the y is up here. 0, 4, 0, 1, 2, 3, 4 is right here. 1, 2, 1 on the x, 2 on the y is right there. 2, 1 is right here. 3 and half, now let me show you, from the origin, if you go out 3, 1, 2, 3, and then halfway up, it'll only be right there. So halfway up is right here. Sorry. And then the next one would be 4 and 1/4, which is half of the half. We know it's even closer to the x-axis, 1/4 of the way up. Now we know that the next one's 1/8 and 1/16 and 1/32 and 1/64 and 1/128. It gets closer and closer to 0. So on the parent graph case, it gets closer and closer to the asymptote y equals 0. But that's a parent graph. And we know that our actual graph involves this -2k value. So we need to take this whole graph, parent graph, and move it down 2 units. Now let's move it down 2 units, and I want to graph it in blue. So this top dot is going to come down 2 units, and I'm going to put a blue dot right here. And I'm going to do for the same for the rest of the coordinates. I want to move them all down 2 units each. Now, as you could see, the asymptote is the k value, right? So the asymptote of this original equation is -2, so you're going to write the asymptote as an equation y equals -2. And if you actually draw that dotted line at y equals -2, that's where your graph will infinitely approach but never actually touch. So our graph are the blue dots, not the red dots. Let me connect those blue dots. And then you're going to draw it like if it's actually touching the asymptote, even though we know it never actually touches, just infinitely approaches. You put an arrow up on that side and you're done. That's your final blue graph. We already know that the final blue graph has the asymptote of y equals -2. That was easy. Right from the beginning, you could state the asymptote. We already know that this is a decay function because the base is less than 1. What else? Let's state the domain. Yep. The domain for all these, whether it's growth or decay, is x equals all real numbers. Now the range, we're going to talk about the y values. And the range, it's going to be y is greater than or maybe less than. It's either above or below your asymptote value. So is this blue graph above the green line or below the green line? It's above, right? So as an inequality, we're going to say that our function y is above the green line, which is -2. So you're going to say y is greater than because it's above -2. So we've stated our domain, we stated our range. So check us out. We've done the domain, we've done the range, we've done the asymptote. Y intercept. Okay, so for the y intercept, we need to see where the blue line crosses the y axis, which is at this coordinate right here. So that's the coordinate 0, 2. So the y intercept, y int, is the coordinate 0, 2. Our blue line crosses the y axis at the coordinate 0, 2. Right here. And that's about it. That's all there is to say about this exponential decay function. So you're going to do this on every single one of these. Maybe I'll make a video later explaining all of these. It'll be a really long video because it takes a while to explain every single question. But at least now you guys have an idea on how to start graphing. And this was an exponential decay because the base is 1/2. Now, how about this one over here? Is this decay or growth? Growth, because the base is 2. Okay, the base is 2, so that's why it's growing. Should we do one growth function? Yeah? Okay, which growth function would you like to see? We already did number 1. That was a decay function. Let's do number 5. That one's a growth function. All right, let's do number 5. Okay, so let's do number 5. Again, we're going to ignore h and k, which we only have k. I box it in to ignore it. I make an xy table. Plug in consecutive integer inputs. And just because I went from -3 to +3, it doesn't mean we're going to use all of them. Let's plug in the easiest one. The easiest one to plug in is 0. So if you plug in 0, it's going to be 4 to the 0 power. And 4 to the 0 is really just 1, right? And 1 times -1/8 is -1/8. So when I plug in 0, I really do get out a -1/8, which is hardly anything. Okay, -1/8 is hardly anything. Okay, now instead of plugging in a 1 right there to see what I get, instead of plugging in a 2 right there to see what I get, I'm going to use this growth factor. It's a growth factor because it's greater than 1. If it were less than 1, like if it were a 1/2 or a 1/4, then it would be a decay factor. But I know it's 4, so it's going to grow. So the 1/8, the -1/8, it's going to grow in a negative direction. All I have to do is multiply it by 4, and I'll get the next output. So if I multiply 1/8 times 4, I am going to get 4/8, -4/8 that is. Now -4/8 reduces down to -1/2. Are you with me? So that's the coordinate 1, -1/2. Maybe I shouldn't have written the 4/8 there, it might confuse you. But when I multiply by 4, I get -4/8, which reduces down to -1/2. Now for the next one, I need to take that -1/2 and I need to multiply it by 4. What's -1/2 times 4? That is -2. That's right. And for the next one, I need to take that -2 and I need to multiply it by 4 again. And what do I get? -8. I hope everybody's seeing this. So if I know that going this way, I'm multiplying by 4, multiplying by 4, multiplying by 4, The next one's going to be too big. It's going to be off the graph, so I'm not going to plug in a negative 32 right there. I'm not going to write the negative 32. Going backwards, it'd be dividing by 4, or it's the same thing as multiplying by 1/4. So 8 times 1/4 is 2/4. 8 times 1/4 is 8/4, which reduces down to 2. Or think of it as dividing, right? 8 divided by 4 is 2. 2 divided by 4 is 1/2. 1/2 divided by 4 is 1/8. And 1/8 divided by 4 is 1/32, and it is negative. And it's already too small. You can't even draw that difference there. Okay, so let's plot those points. We do have the coordinate. Let me go with this one first. -1 and -1/32. So -1 on the x and -1/32. It's so small you can't even actually show that. It looks like it's on it itself. -1, -1/32. 0, -1/8. So 0. You don't go left or right. -1/8, it's still so small you can't really even tell. It looks like it's still on that x-axis. And then we go to the next one, the 1 and -1/2. That one you will be able to tell. So go 1 on the x, and negative halfway down. You'll be able to tell the difference there. So 1 on the x, negative halfway down is right there. And then 2, -2, that one's nicer. 1, 2, 1, 2, it's right here. And then 3 and -8. So 1, 2, 3, -8 is way down here. So this is the parent graph. And this way, it's just approaching your asymptote, which is 0 on the parent graph. But this is your parent graph, and you don't want a parent graph. You want the final graph, including the k shift of 8. So I need to take this whole graph and move it 8 units up. So what I'm going to do is, I already know that this is the asymptote on the parent graph. If I move that asymptote 8 units up, or if I just were to draw my asymptote, we know it's y equals 8. That's going to be this line right here, this dotted line crossing the y-axis at 8. So our line, our blue line, is going to end up right there. All I need to do is shift all of these coordinates 8 units up. So this one goes up 1, 2, 3, 4, 5, 6, 7, 8. And then this one moved 1, 2, 3, 4, 5, 6, 7, 8 will be right there. And so on and so on. So here's our blue graph. Connect the dots, put an arrow on it, and that's your final graph. Let's state everything that we need to know, or everything that we can about this blue graph. The domain is always x equals all real numbers. The range are your y values, and that's either above or below your asymptote value, which is y equals 8. So what do you say? Is this blue line above? Did I say -8? No, I'm sorry. Is it above or below the y value of 8? It's below, so we're going to say that our range is y is less than 8. That's our range. Y is less than 8. For the y-intercept, it's kind of difficult, but you could actually do this on a calculator or in your head. Because if the original parent graph crossed the y-axis right here at 0, -1/8, and you moved it up 8 units, so that'd be like adding 8 to the -1/8, which would give you 7 and 7/8. So your y-intercept is 0, 7 and 7/8. Because if you took the 8 that you're adding, 8 minus 1/8 would be 7 and 7/8. I hope that kind of makes sense. So that's 2 examples of how to graph. One's exponential growth, one's exponential decay. Let's flip this paper over and see the rest of this homework. I know you guys might be thinking, man, it's a lot, but the rest of this is a little easier. Number 7, we need to state whether this is a growth function or a decay function. So it all depends on your base. So is your base less than 1? Now remember, this negative sign is part of your a value. Your base is just 3. Okay, so this base is greater than 1, so that's an exponential growth function. Yay? So the base, the b value is actually 3. So because the b is greater than 1, it's a growth function. growth. Okay, what about your asymptote? Y equals 2 is your asymptote. Perfect. Okay, what else is it asking for?
Range.
The range. Okay, so this is where it's a little confusing, and I probably won't ask this on a test. You know what, let's scratch that out. That way we don't confuse anybody, the range. I mean, this will be y is less than 2 because the whole thing would be below the asymptote 2. Let's not even worry about that. Let's not do that. Okay, so number 8, is it growth or decay? It definitely is decay because the base, as you could see, is 1/3, which is less than 1. So that's definitely decay. Decay. Okay, and the asymptote is what? Y equals -1. So that's pretty easy. Let's look at these guys down here. I'm sorry. So from left to right, if your graph approaches a certain value, then it's a decay function. Check this out. From here, from left to right, it is approaching a certain value, your asymptote value. And so this is a decay function. You can put a D for decay. And the asymptote is y equals 0. So how about this next graph? Is it growth or decay?
Growth.
Everybody thinks it's growth, but it's actually a decay function. Now you're probably thinking, no, it's going up, it's growing. Okay, it is true that it's going up, but it's approaching the asymptote value. And from left to right, if your graph approaches a certain value, the asymptote value, the k value, then it's a decay. It decays to the value of 4. So this is your asymptote, which is y equals 4. You need to write that down. And this graph decays from left to right. It actually decays to that value of 4. So this is a decay as well. So this first one was a decay. The second one's a decay. How about the third one? So this one's definitely from left to right, growing in a negative direction. So that one's growth. Growth. And your asymptote is what? Y equals what?
4.
Y equals 4. That's your asymptote. So you should be able to go through all of these and state whether it's growth or decay, and then state the asymptote. Okay, for the final section, guys, it says state whether the following tables represent an exponential growth, exponential decay, linear function, or just a relation, which is none of the above. I shouldn't have said neither. I should have said none. Okay, so I give you some tips. It says the output of a linear function when the inputs are in consecutive integer order will either increase or decrease by a constant value, which means adding or subtracting. So, for example, a linear function would be something like this one right here. The inputs are in order from -2, -1, 0, 1, so they're in order. And right here, 0, it's not an exponential growth. You might be thinking, oh, it's growing. You might be thinking, oh, it's growing from 0 to 4, it grows. It's not an exponential growth. It does grow, but it's linear. It's a linear growth because 0 plus 4 is 4, and 4 plus 4 is 8, and 8 plus 4 is 12. So this is a linear function. There's a common difference in the outputs. Okay, so this is linear. And if you want to see a exponential growth function, that'd be one like this one right here. Because as you go down 3/4 times 2, it'll give you 6/4, which reduces down to 3/2, times 2 will give you 3, times 2 will give you 6. So this one is a exponential growth function. Growth, and the base, the growth factor is 2. So I hope you guys understand that. This will be online. Please finish up your homework right now in class.